Thank you. Okay, so very good afternoon, sir. 1.5 present over here, and I have been told to give the concept of optimization. I have examples, simple examples, because all the branch students are present over here. So generally, simple problems we will take and how the optimization technique can be applied to solve those problems. We will see. Next slide. Now, what is optimization? The optimum word is a Latin word, and that means the ultimate or the best. And so, optimization refers to getting the best out of what you are saying, out of the from the problems. So, best means it may be a minimization or maximization. Okay, and so optimization means there will be a number of variables, such variable. So we'll search those variables such that our goal is met. So goal may be a minimization problem or maximization problem. Next slide, if you see, I have taken some example. Next slide. Yes, this one. Say, if the problem is the designing of a car or vehicle design. So in that case, the problem is maximize the fuel efficiency. So that will be a maximization problem. And similarly, stock investment, if you talk about the stock investment, minimize the risk to our objective. So the objective will be a minimization problem. So similarly, investment, maximize the profit. So in many cases, optimization is either minimization or maximization, depending on our requirements. Next. So again, the optimization there may be a local minima and there may be a global minima. So local minima, I will give one example. Suppose in first year there are 7 sections. So in section A, the topper, he may be our local minima. Throughout all the 7 sections, who is the topper, he will be our global minima. That means one local minima will be our global minima. So our objective is to find the global minima. There are some techniques which are suitable to find the local minima only, and there are some techniques which will explore wide search and in most cases will provide the global minima. Okay, so minimum it may have some sign function, some cosine terms, and there will be some range of the variable 0 to 20. So there are many maxima and many minima. If you plot the f of x versus x value, you can see there are many maxima and many minima. So in this case, the conventional method like finding the derivative of the function and equating that to 0, this will not work here. Other approach is you can do an exhaustive search. So exhaustive search means you take all the possible value of x. So x is taken from 0 to 20. So what is the tolerance? Suppose first value is 0, next value is 0.0001 like this. So up to 20 means around 2 lakh times you have to repeat. False, na? Okay. So we are talking about this problem. There is a complex problem, and for this type of problem, if you would like to do that adjective search, when one person searches that one, it will take time, and he cannot find that one. If instead of one person, the 20 persons are searching that one, that is a multi-point search. Many possible solutions. So it is easy to implement and numerically robust. The soft computing techniques. Whereas the conventional computing is the heavy computational burden and slow convergence. So only one thing is you may find a global option. There is no guarantee that the solution will be the best solution, but in most cases you have to it may give us the global option best solution. And it can produce alternative solutions. In many cases, we will see in the last multi-objective optimization. So a set of solutions will be given. So as per our requirement, we can pick up which solution is best for our needs. Next, so there are many techniques like genetic algorithm, particle form optimization, differential evolution. So these are promising algorithms for handling the optimization techniques. So all have some common. All are population-based search algorithm, and they are versatile, and they have the ability to optimize the complex problems, and that can be applied to any type of objective function, whether it is differentiable or non-differentiable. Next, this is the list. This every day a new optimization technique is coming. So you can try this optimization. Again, one more thing. According to one theorem that is known as the no free-lunch theorem. So no optimization technique is suited for all type of problems. For a particular problem, a particular optimization technique will give us the better results. Or a group of the problem, so one technique will give. But there is no guarantee that the same technique will give us better result for all type of problem. So that means for your problem, you can apply a set of optimization technique, different optimization technique. For your problem, a particular optimization technique may give the better results out of the many available optimization techniques. Next, this one, the same concept we will take. How to solve that one? The first approach is to exhaustive search with a precision of 10 to power minus 4 into meg. Then you have to repeat it 2 lakh times. We will do one more approach, that is a blind generate and test. So you generate a random possible solution and test the solution and see that how good it is. Then you modify the solution and repeat until the solution is good enough. So that means instead of taking this 2 lakh time, so we will have do one other approach. So initially you take a set of solutions and then you test those things and you keep the good solutions, bad solutions you remove and modify the good solutions and repeat this process. But here problem is how to modify the solution and how do you know that the solution is a good enough. Okay. Next. So this dumb approach may work sometimes but not always because many practical problems are non-differentiable, non-continuous, non-linear, and there are so many restrictions, constants. So in that case, what you do, you have to go for the soft computing technique. Next, I will take one example. Then we will extend with the soft computing. So that less dumb approach is to generate a set of random solutions. So 5 solutions you generate randomly, like 2, 5, 8, -1 and -4. And test the fitness of each solution. If x is equal to 2, what is f of x value? If x is equal to say 5, what is f of x value? Like this you calculate that one. So it is coming as 10, 25, 58, 13 and 34. So you rank the solution. What is the worst? Third one is the worst. So that our objective is to minimize this one. So it is giving third one is giving 58. So that is the worst. So like this you rank third, fifth, second, fourth, and first. So remove this bad solution. So third and the fifth you remove. So that means 8 and -4 you remove. And modify some good solutions. Good solutions are first and fourth. So first and fourth, how to modify? One way is you can take the average of that ones. So if you take the average, you are getting as say 0.5. So now 0.5 will be a new point which will replace our bad solution. That 8 and minus 4 will replace. So if you can see that if f of 20.5 put a, so it is giving better result compared to the earlier points. So this process can be repeated. So this is what the genetic algorithm does. Next, this is the on this concept the genetic algorithm, that is a search technique or optimization technique. It is developed and it got popular in late 80s, and it is based on survival of the fittest. Whoever is the fit, he will survive, and whoever is not fit, they will be eliminated. So that is happening in our generation now. Who is fittest only will they will survive. So this genetic algorithm maintains a set of candidate solutions known as the populations and repeatedly modifies them. So genetic algorithm selects the good individuals from the current population to be parents and uses them to produce the children for the next generation. No, in most of the cases we have seen that if the parents are good and brilliant, then the children will be brilliant. No? If both father and mother are doctors, most likely the children will be the doctor. But not always, but in most cases. So, and in some cases, even father and mothers are very illiterate also. Sometimes the son will be as success. So that is also taken into account in our genetic algorithm. So there are two operators. One is crossover and second one is mutation. So mutation means a bad parent may produce a good child. But the chances of happening this is very less. So that is taken into account in genetic algorithm. But in most of the cases, good parents will produce the good child. So that is our crossover operation. Next. So this is the scheme of genetic algorithm. So first it will generate a set of population and it will evaluate the population. So that is known as fitness function evaluation. Then the selection, the good solution will be selected. So in most of the cases, there are many selection methods. You do choose one method of selection. Then the two genetic operators are applied, like crossover and mutations, to produce child for the next generation. So new generation now you get, then the process will be repeated from the second step onwards. Again, the fitness will be evaluated. Again, the good parents will be selected, and we will perform the crossover and mutation operation, and it will continue until the stopping criteria is met. Next, next slide. So there are these are some fundamental issues. If you apply want to apply the genetic algorithm to your problem, then these are the fundamental issues like solution representation. How to represent the solution? So there are many types like binary or floating point or integer or real number. Similarly, the initialization. Initialization can be a random one or from other method you can choose the initialization. And next, the selection function. How to select the parents. One is roulette wheel or ranking, geometric ranking or linear ranking. There are many methods. Then the genetic operators like crossover also many types, like simple crossover, arithmetic crossover, heuristic, and mutation also many types of mutation, and as well as the termination. Because GA does not know when to stop. You have to specify when to stop. So you have to specify the number of generation or population convergence or lack of improvement. Some criteria you have to specify. Then only it will stop. Otherwise, it will go on increasing the generation and searching the variables. Next. So these are the steps actually. So GA begins by creating a random initial population. So, but fortunately, these are the concept you have to understand, but the program is there available. So later on, we will see how to make use of those programs to solve our problems. But before applying that one, you should know how it works. Okay, no need to write the program of this genetic algorithm in detail because nowadays it is available in that toolbox, MATLAB toolbox, and it is safe. Simply you will use those syntax. those common. So GA begins by creating a random initial population. So first step is a set of you have to specify what should be the population size, either 20 or 30 or 10. You have to specify. So accordingly, you will create a set of solution initially. Next, GA uses this individual in the current generation to create the next population by the following steps. So score each member of the current population by computing its fitness value. Means how good the solutions are. Like in earlier cases, we have tested what is the f of x value for the initial population. So what is the objective function value in this case? So it will calculate the objective function value of all the populations. Next, it will select the members called as parents based on their fitness. So most cases, good solutions will be selected. Then the elect individuals are passed to the next population. Some cases, good solutions are directly passed to the next generation also. Then the produce children from parents by crossover and mutations and replace the current population with the children to form the next generation. So this loop will continue until the stopping criteria is met. Next, so these are some terms. Oh, sorry, stopping criteria. The generation or time limit or fitness limit, stall generation, stall time limit or function tolerance. So you can specify. In most of the cases, the generation is taken as the stopping criteria. Number of generations. Suppose 100 generation, you got to know that the algorithm will stop. Next, these are some terms. Already we have discussed this one. Population, generation. Next, so these terms we will omit fitness value, best fitness value, parent and children. Next, problem. So the problem setup and results. So first you have to define a fitness function. So if you want to apply the genetic algorithm optimization technique to your problem, first you have to define the objective function that we want to minimize. So by default, GA minimizes. If f of x value is given, it will minimize that one. But if you want to maximize that one, you can put a minus sign or 1 by f of x. So I will see one or two problem. We'll see the minimization problem as well as the maximization problem. And what is the number of variables? Okay, so this number of search variable. For example, you are designing a PID protocol. So search variable will be the KP, KI, KD values. Or if you are designing a box, so what should be length and what should be the width? So length and width are the search variables. So search variable and objective function is what is your objective function? When you design a box, maybe your material should be uniform. So material minimization is our objective function. If you design a controller, maybe performance should be maximum or the error should be minimum. So accordingly, what you want to minimize or maximize, you have to specify. So there are many constraints in real world problem like linear inequality constraints and equality constraints. There are bounds means a particular variable like when you are designing a box, the length should not be more than say 20 centimeter. So 0 to 20 is the our bounds. So there will be some bounds. Similarly for width also there will be some bound. So for all the search variable there will be a bound, and within that range only you have to search. So lower and upper bounds. And there may be some non-linear constant functions also. So that also we will take one or two examples we will take. Then it will be more clear. Next slide. Now we will make use of this toolbox, this global optimization toolbox. In this case, there are many optimization methods. One of them is genetic algorithm. Nowadays, the particle sum optimization or pattern search optimization or AppMin. There are many optimization techniques. The routines or the algorithms are available. We can apply that one. But we will take only one example, the GA. Only the instead of GA, if you write PSO, that program will say PSO program will be implemented in that case. So the global optimization toolbox provides methods that search for global solutions to problems that contain multiple maxima or minima. Means like this complex problem, you can apply this global optimization toolbox. So it includes the global search, multi-search, multi-stack, pattern search, genetic algorithm, simulated learning, even PSO, and there are many methods. Okay, you can use any one method to solve your problem, or you can apply all the method, and you will get a conclusion that for our problem, this is the best method. Like this, you will get a problem. And this can be applied to any optimization problem or controller design, model, order reduction, tuning, and there are many other problems. Next, now we'll take one example. Will be more clear. So to use the global optimization function, first we have to write a file that computes the function you want to optimize. So let us say this is the function given. F of x is a complex expression is given in terms of x1 and x2. Our objective is to search the variable x1 and x2 such that f of x is minimum. Okay. So how to write this one? So first you have to create a M file where f of x is calculated. So you have to use the MATLAB expression for that one. So next slide, this one. So that function file is written in blue. The same thing. That expression, if you want to write in MATLAB, for example, x1 square. That means x of 1 square means it will take like this one. No? Those who are using MATLAB, they can understand this concept. No, if probably there it is not visible, I think. No, the slide. Anyway, this first step is the file. You have to create a file that computes this function. And there are two variables here, x1 and x2. So select new script in the MATLAB file menu, then write these expressions and save this by giving some unique name. Because MATLAB there are some thousands of commands. No. So, here it is audible. Audio. What I am saying, when you are creating a new file, you give some unique name because there are thousands of MATLAB commands and they are stored given by using some variable names. So if your name and that name matches, then it will override that one and it will create problem later. So that's why some unique name like say my underscore function. So in most of the cases underscore is not used in MATLAB. So you can use your initial and underscore or some number. Okay, to save that file. Now once you write a file in MATLAB and when you are saving, you give some unique names like using underscore or number. For example, here this function file is saved as my underscore function. If you want. Next. This is what the maximization and minimization problems. Okay, so global optimization toolbox by default it minimizes, and if you want to maximize this one, you can put minus of f of x. Minimize minus of x means f of x means it will maximize, or otherwise you can minimize 1 by f of x. So then if f of x is maximum, 1 by f of x will be minimum. Clear? What you want to minimize? That you specify here. Here. If you want to minimize, simply write minus. Okay. So minus sign means it will maximize. Next. This you skip this one. Next. Okay, this one. Now how to run this one? So to run this genetic algorithm with the default, first already you created that function file. And you save that one by using some unique name like my underscore function. And the number of variables are 2 here. No, x1 and x2. If you see the problem, the number of variables are 2. So in the MATLAB command window, you simply enter these syntaxes. X f value is equal to GA, and with a function handle, that function you call my function, and 2 is the number of variables. So when you write this syntax in the MATLAB command window and press enter, it will give the two values, x value and f value. X is the final point, so x will have the two columns. The first column will be the x1 and second column will be the x2. And the objective function value will also we will get as a when it is run. The algorithm is run. So only thing is you to express the problem in the using MATLAB. Okay. Next. So there are many syntaxes. That is the simple syntax where only the function name and number of variables you have entered. Then you can enter the equality and inequality constants a, b, and a equality and b equality, and then you can specify the bounds, lower bound and upper bound, lb and ub, and there are some other options like say integer count. If you want that one variable should be integer, the other variable can be any one set. Fraction, it can be a fraction. So that option we can enter integer count and the exit flag. Okay, there are many options. We will see one or two here. Say next slide will go. These are some explanation about this. What you are writing? Directly you can write x is equal to GA, and GA is already a program is written and saved using the name GA. Okay. So when you use that one, it is the GA program is run and it gives the results. So simply that one first line means it will give us the only x values. Okay. And input is the function where the objective function is calculated and number of variables and bars, number of region values. Similarly, A, B, if you want some inequality constant, you can enter that one. If there is some inequality or equality constant, that also you can enter it. If there are bounds, means the set variable should be in a particular range, then also you can enter these things. Next, directly we will take one problem, then it will be more clear. Next. Similarly, the other. Okay, there are many options available. As per your option, use that syntax. This is the objective of this one. Next. So, if you don't specify anything, so GM will take the default options and like the population you have not specified. So, population by default 20 population, depending on the number of variables it will take, so 20 or 50, and the algorithm will run. Similarly, stopping criteria we have not specified. So by default, already there are some parameters. I will show that parameter also. So it will run that one. Next, this is the same thing. That expression only. Like this, you will get the end of the result. The command window x GA your fitness function and number of variables. There will be two columns for x. The first column is x1 and second column is x2. So here you put only x. If you put x and f value, then to the function value also we will get as output. Next. So this is the default. So like population size by default it is 20. And if you see there are many options. If you don't specify any other options, these options are used. Okay. And you can change these options. So instead of population size 20, suppose you want say 100. So there is one option where you can change the population size. Similarly, all these things you can change as per your requirement. Next, this is how to set and change the options. Okay. Like initially you define the option is there is a command optimum option GA, the maximum time 300, and you display equation. And similarly, the maximum time any value you can set, okay, depending on your requirement. Next, Now if you put x and x value in this case, you can see the function value and x value both are coming, and it will exit flag which will describe the exit condition of the G. Why the G stop? Maybe the maximum generation reach or maximum tolerance reach. So that way it will specify. Next, there are many conditions here. This we will skip. Next, this is the same thing. Next, population score. We will take some problem. Then it will be more interesting. Next, the same thing is repeated here. Next, additional output arguments. No, like output, exit flag. These things we will skip. No, when you have understood the basic concept of GA, then we will take some problem and how to utilize the GA to solve those problems. We will see. Come to the problem. Skip. Next. This is some visualization you can add. Next. Skip this one. Here one more. The constraint optimization. Constraint means suppose that is how your objective function f of x is an expression is given, but there are some linear constraints or non-linear constraints, and so there are some bounds. So how to solve in this case? So in this case, for constant also we have to write one file. So one file is for objective function, one file is for the constant. Next, there I have written here. So the first file is the objective function file, and we set that using some unique name like the simple underscore fitness, and that is the MATLAB expression for the our f of x file. Then the constant is this one. So for constant, you can see that this is the constant 1.5 plus x1. You go to previous slide. This one. So this constant is x1 x2 plus x1 minus x2 should be equal to plus 1.5 is less than equal to 0. So this is a non-linear constant. So we will make it into two equality constants. One is 1.5 minus this one should be equal to 0. Second is x1 plus x2, x1 x2 plus x1 minus x2 minus 1.5 should be equal to 0. Next slide you go there, you will see it. So there are two now here. So 1.5 minus this one, and the second one is one more constant. So these constants are included here, and next, then you define your objective function and number of variables and the bounds, lower bound and upper bound. So lower bound 0 0 means both x1 and x2 minimum value is 0. Upper bound 113 means the upper limit of x1 and x2 is 1 and 13 both. Then you enter this format. So x value j, your objective function you define, number of variable you define. Then if there is no equality and inequality constant, simply put the square bracket. Then the bounds, lower bound and upper bound, and the constant functions. Then you will get, when you enter these in command window, we will get the outputs. So two variable means x will have the two columns of first value is x1, second is x2, and the function value also will get. But one thing you have to remember that genetic algorithm always starts with random initial population. Then the algorithm will evolve. So these random population may be by chance there may be a good solution or there may be bad solution. If it is good solution, immediately we will get the better solutions. So if it is bad solution to begin with, then it may not reach the global optimum value. So that's why if you apply the GA or any optimization technique, you will not get the same value at end of the iterations. So that means you have to apply it multiple times to get the conclusion. It is like when you toss a coin. When you toss a coin, it may come as head or it may come as tails. So then you cannot say that whenever you toss a coin, you will get head as your output. But if you toss the coin say for 50 times, maybe 24 times you will get head and 26 times you will get as a tail. So then you will get a conclusion, correct conclusion that almost 50% of the time you are getting head and 50% time you are getting as tails. So when chance is involved, like genetic algorithm, when it is initial population is randomly generated, so you will not get the same result depending on how good the initial populations are. So that's why the solution is you have to apply multiple times to get the solutions. Next, so like this you have to enter, then like you have to define the objective function, number of variable and bound of each variable, and if there is a constant function, you have to and options also you can change. Like suppose you want to display the result, or you want to plot the best fitness function, or display the iteration result, then you can add these options. And finally, in the command window, you enter the last line GA with objective function with all the options. Next, so like this you will get because you have given the option of iteration count. The first generation, what is the f(x) value, and in second generation, what is the f(x) value? Like this, we will get. And whether the constant is satisfied or not, also we will see. Next, we will take some problem now. Then it will be more clear. Next, we will go to the problem P1. This is mixed integer. This also we will go to problem. How to set your problem, exercise problem, no other problem. Next, region problem. Yes, here. This is one total one only we will take. Next region problem will take. Suppose the problem is find the two positive number whose sum is 300 and whose product is maximum. Okay, a simple problem is given, and how to apply the GA to solve this type of problem. So first you have to find what you want to minimize or maximize. No, because optimization means either minimization or maximization. So the product is a maximum. That is our objective. So our objective is maximization of product. Suppose there are two variables. Because it is two positive number. Number of variables will be 2. So if A and B are the two positive numbers, product is maximum. A into B should be equal to our objective function. So f of x, you write the fitness function for problem 1 is x1 into x2. And because by default GA minimizes what? The objective function, and our problem is a maximization problem, you have put a minus sign here. So y is equal to minus of x1 into x2. So that is our objective. But there is a constant whose sum is 300. So x1 plus x2 should be equal to 300. So this is a constant function. No. So the constant directly you can specify as a constant or as a penalty function you can add also. Next slide. So constant it is mentioned in this one. So equality constant is expressed in two inequality constants. So 300 minus x1 minus x2 should be equal to 0, or x1 plus x2 minus 300 should be equal to 0. Okay, so that means the sum should be equal to 300. So that is equality constant that is converted into two inequality constant and expressed in this manner. Okay. Like this one, x1 plus x2 minus 300 should be less than equal to 0, and 300 minus x1 minus x2 should be less than equal to 0. Next, you specify all the problems. What is the objective function? Where you have written that expression for objective function, number of variables, and lower bound and upper bounds are 1 and 300 for example, and integer count. Both the numbers should be integers, not fractions. So integer count is 1 and 2 both. Then in the MATLAB command window, enter that sentence x f value is equal to GA. First you define the objective function, number of variable, and there is no equality and inequality constant, but constant functions you will include lower bound and upper bound, and these constant functions and the integer count. And then you can collect A is the first value, B is the second value, and product is A into B, and sum is A plus B. You can verify the results. Next. Similarly, many problems we can apply. Okay. The only thing is you have to previous. But your specifying the objective function is your first step. Whether you want to minimize something or maximize something. So that is sum of 1 and 10 times the other is a minimum. So that is a minimization function. So maximize the enclosed area. So this is our, you find the area, and that should be the maximum. And maximum volume or maximize the enclosed volume. Okay. So these are some problem. One or two design problem also will take. Next, this one. One problem we will take how to handle this design problem. Right? So suppose the problem is a company needs to design a cylindrical can that holds 475 cubic centimeter of fluid. What are the dimensions of the can that would require the least amount of material? So this is the problem, and how to apply the genetic algorithm to solve this problem. So first is what is your objective function? What you want to minimize? So it should require least amount of material. So material should be minimum. So what is the material? Material at the top, material at the bottom can you see, and the surface. Okay. So if the radius is r and height is h, and the total surface area will be equal to area at the top, area at the bottom plus area at the outside. So pi r square plus pi r square plus 2 pi r into h. So the surface area is equal to 2 pi r square plus 2 pi r h. So this should be the minimum. Okay. And our objective search variable is r and h. What should be the radius? What should be the height? Surface area should be minimum. Plus there is a one constant. The can should hold 475 cubic centimeter of fluid. So whatever may be the r and h value, the volume should be equal to 475. So volume is pi r square h. Pi r square h should be equal to 475. So there are many ways to include this constant. One is like equality constant or inequality constant. Other approach is you can use the penalty function approach. So you attach some penalty function to this constant hydrogen. So that is volume minus 475. And you attach some penalty to this one. So whenever volume is not equal to 475, some additional penalty is attached. I will show you. Next slide. Like this one. So first thing is you have to define the objective functions. So in one objective function only the constant is included. So r is the first variable x of 1, h is equal to the second variable x of 2, and 2 pi r square plus 2 pi r h. That is the surface area, first part. Second part is our penalty function. So we have given a high value, say 1000 into absolute of pi r square h minus 475. So that means volume minus 475. So whenever that is not satisfied, whenever pi r square h minus 475 is not equal to 0, then we will get some value and you are adding that one, multiplying that to 1000. So we will get a high value. And because GA by default it will minimize this one, I have expressed this one here. Here the first part is the surface area of the can, 2 pi r square plus 2 pi r h. And penalty part is the second part, 1000 into absolute value of this volume minus 475. So whenever pi r square h volume is equal to 475, so that part will be equal to 0. And when this is not equal to 0, then it will be a high value because you are multiplying by a high value 1000. And because GA tries to minimize the objective function, so GA will search only those value of r and h when that part is minimum. Okay. So by default r and h it will search only those r and h value when that second penalty part is 0. So that means if that part is 0, now GA will minimize the surface area, remaining part only it will minimize. So by default it will make that one as 0, and this one cannot be equal to 0, but it will try to minimize the first part. Yes.
Penalty
means whatever you specify, y is equal to this one. So that part, total part, it will try to minimize this one. So when it tries to minimize this one, to minimize that one, what should be the value of r and h? It will search. Okay. So if you see first part, that is the surface area. No, surface area is 2 pi r square plus 2 pi r h. And there is a constant here is that the volume should be equal to 475. Okay. So that is included as a penalty function. Like 1000 into absolute value of pi r square h minus 475. Okay. So because it will try to minimize this one. So what is the minimum value of second part? Minimum value is pi r square h is equal to 475. Okay. If it is not equal to that one, absolute value we have to use. Okay. So that means you will get some value there. And multiplying by 1000 means a high value will get. So that will not be a minimum value because your GA will try to minimize that one. So it will get a more than the minimum value. So that part will be ignored. So as a third sentence about a GA tries to minimize the objective function. So that means GA will search only those R and H value when that total part is minimum. So R and H will be such that pi r square H will be equal to 475. So that part will be 0. So only this part, that means the remaining part is only minimized. That is the surface area. This is one way of doing this one. So I find it easy way of doing this one using penalty function method. How to minimize this one? You can use the constant also. Convergence is faster. Conversion expression is easier. Otherwise, one more function you have to write for equality constant or inequality constant. Or that also you can include this. Here only in one function you are dealing with both the objective function minimization as well as the constant also. But this is not the only way. There are other ways also. Like earlier way, you can use the constant function and specify the constant that one and use it. But in some other cases, because you are using the GA, the constant is available here. But the other toolbox, the constants are not available. So in that case, you have to use this penalty function methods. No, like the GW, suppose you have downloaded and you have to implement. So there, that constant option is not there. Only GA, because it is inbuilt, it is available. So in that case, it is better to use the penalty function methods to minimize that one.
Sorry. When you are switching from a larger space, solution space is there. When you are putting no constraints, lot of time it will take. If you are putting the constraint, what will happen? Your soft space will be squeezed. So penalty function does certain kind of thing. So that means your soft space will be reduced, so that it is much easier to very quickly can pick the minimum value of the constraint. That is the idea of penalty. But this is not only way.
Not the only way. There are other approaches also. This is one of the ways. Okay. Next. Next slide. Here, this is the MATLAB. So total now objective function is first defined, and you give some unit name as I said. Obj function underscore p1. Number of variables you define. Lower bound and upper bound of each variable, and you can specify some change some option like generation, stall generation 100 you can, population 200, maximum generation 1000. So this you can change as per your requirements. Okay. Then as I said, because GS starts with random initial population, you cannot get the best result in a single block. So you have to apply multiple times. So you can put a loop, say, number of runs is equal to 20 and store the result. So you create a variable system, SYS say, and you put a for loop, say, for I is equal to 1 to number of runs. So 20 times it will run the GA, and each time the right portion is the main GA command. No, X and F value and GA objective function you have defined, number of variables you have defined, and no constant here, equality and inequality constant, only square bracket, because you have included in the objective function that constant, and the number lower bound and upper bound and other options like generation and population. And each generation you store the result. So in R is equal to the first variable, and you store the result as system that result. Similarly, height also you collect and store, and volume also you can calculate and you store the results. And the material required, the surface area also you can calculate. Okay, and you can print the result also. The R value, H value, and the volume and the material required. That is the surface area. Each case. And objective is the lowest of that one. So from the stored result, you can calculate the lowest of minimum. The system where you store the materials. Next, to run this one now, These 20 results you will get in the MATLAB command windows. Okay. And you can see that in every time you are getting different results. But if the number of runs are more, maybe you will get the almost same result in each time. So lowest material is now you can see that all the cases the volume is coming as 475. The constant is satisfied for every case. A different R and H value it is searching and it is giving that result. Those values only it is giving for those R and H value when the volume is 475. Automatically you are calculating the volume also. And material because as I said based on the random initial population the algorithm is evolving. Maybe if you increase the number of generation or number of population you will get the same result. But it is better to apply multiple times. Any optimization technique you should apply multiple times to get the results. So lowest material we will get. Okay. Next. Similarly, some other problem also we can specify. So like this is one more problem. The top and bottom margins of a poster are 5 centimeter and the side margins are 3 centimeter and area is given 360 square centimeter. Find the dimension of the poster with the smallest area. That means our objective is area should be minimum total. So total area means now area will be x plus 6 plus y plus 10. No. So 5 in two sides means 5 plus 5 10 it will add. And for x 3 means 6 it will add. So our objective is x plus 6 and y plus 10 should be minimum. Okay. Smallest area. So objective function L is equal to the first one and then width is the second one. So L plus 6 and W plus 10 should be minimum. Plus in the same way we have added that say penalty function. What is penalty function? Area of that printed metal should be 360 square centimeters. So L into W minus 360. In the same manner we have added that penalty function here. Only thing is because already the programs are available. According to your problem, how to define your objective function. That is one of major steps in application of any optimization technique. Because nowadays the technique routines are available. Next, the same thing you do right and you will paint the results. Okay. Next, similarly one more problem. Same problem. Main objective is the writing the objective function. Probably here you will see what is the dimension of the rectangle with maximum area. So this is a maximization problem. That's why y is equal to minus of that one you put. So maximization means negative you have to put. Next, similarly some problem we can. This is other way of doing. Suppose you want to use the constant. So you can use the constant also instead of penalty function. If you want to include the constant, so you can use a constant function and write one more function there to handle the constants. And this is for the objective function way. So this is designing of a package box cell with sum of length, weight, and height. Objective is to find height, weight, and length. Okay, this will stop. No, next sir will continue. Okay, there are some other part multi-objective, but that I am skipping now. Okay. Okay. If you have any query, you can ask. Already the programs are available in the GA MATLAB. Only thing is you have to formulate your problem. Simply this objective function you have to write, and if there are some constant, maybe in the form of penalty function or using the constant function, you can add those things. No, in the last semester, I think a group of civil engineer students they came for their problem. In this GA with constant optimization, constant minimization, they could solve that their project, final project. Okay. If you have any query, you can ask, or you can, because you are local from VSSUT, you can contact me. Yes, is there any query?
Not a single query.
During that one, Raseshwari asked something.
I guess one program I will talk to you.
Okay.
Something एका department
Sir,
I mean, already published course paper.
So in outputs, results are vary. We are doing problems where the results are consistent.
The conventional or which one?
For example, suppose we found maximum of the function.
Which method you
MATLAB.
MATLAB? No, that depends on the problem. It is not that always it will come different results. Some cases, if it is a complex problem, probably you may not get that results. So that's why it is better to apply it multiple times. But if the problems are simple, in single run also you may get the result. But there is no guarantee that you will get better result. How do you know it is a better result? The better you have to apply multiple times.
We are running 3 times.
To the same result you are getting means the problems are not that much difficult. Na, sir, it is knowledge.
Analytics is the mathematics based upon a mathematics we are doing. Whether you are doing at America, India, Switzerland, it does. But if you are applying for this technique, which you call it heuristic optimization technique, then you are bound to run it. And there is no concrete proof that this method is best. Or you have done your result, that's why I want to run it. So can you give the guaranteed minimum? Guaranteed.
Thank you.
Thank you, sir, for dedicating such an amazing session. It was very nice to have you among us for today's event. Now I would like to request Professor Mahendra Kumar Jena, sir, to present a token of appreciation to Professor Dr. Sidharth Panda, sir. We have completed the first session of today's evening. Now, there is a short interval before starting the second session. We would request the volunteers to escort the dignitaries to the cafeteria for the refreshments.
I stand before you today to introduce a scholar whose dedication to the pursuit of knowledge and unwavering commitment to education has left an incredible mark in the academic world. With a great career span of 32 years, Professor Dr. P.K. Hota sir from the Department of Electrical Engineering from VSSUT Burla. He is qualified in Bachelor's of Engineering in Electrical and Electronics Engineering from National Institute of Technology, Tiruchirappalli, and MSc in Industrial Power Control and Electric Drives from Sambalpur University, Burla, and PhD in Electrical Engineering from Jadavpur University. He has specialization in Industrial Power Control and Electric Drives and Power System Engineering. He has demonstrated an exceptional ability to not only transform information but to inspire and ignite a passion for learning within countless students. He has achieved 71 awards, like the award from the Union Minister of Energy Department, and has developed software for hydrothermal scheduling through evolutionary programming technique at Yale, Bangalore. And like that, has given enormous contribution in various fields and national and international awards. So we extend our hearty gratitude to Professor P.K. Hota sir, whose presence is a great opportunity for enormous knowledge. Please.
Hello.
Hello.
এটা বন্ধ হতে বলেছি। Okay, good afternoon to everybody. First of all, I must be thankful to the organizers for giving me this opportunity. It is not surprise for me that the audience is a bit low, because for this kind of workshops, I expect more audience, because we are entering to 11 branches of engineering. That's why I am a bit disappointed for the number of students or the researchers or the faculty. At the same time, I am also happy to see that few faculty members are there. So it is a driving force for any speaker to come and present or to share his experience. Anyway, without wasting much of time, since the topic when the Master Javanadena, he asked me, sir, you have to give a talk on. I asked him, who are the audience? Because depending upon the audience, talk is prepared. I don't have much time also. Anyway, with a shortcut, that means so many presentations I used to do. So what will be the best suit for this kind of audience? It was a challenge for me. Anyway, I was observing my colleague Dr. Panda who was talking about the opinions. So I will be starting with a little bit of machine learning and artificial intelligence. But the topic will be a real-time practical examples, particularly from the electrical engineering domain it has brought. But anybody can understand, because as you know, it is based upon the optimization. The optimization is not a classical optimization, rather the power of artificial neural network and as well as body system. Both have been integrated. Then it has been applied to a real-time practical power system. Power system problem, I don't think that you will not understand. only what are the mathematics behind that I am dealing. Exact details I will not. Thing is that I want the audience they should understand what is the power of psychology, what is the power of this artificial neural network, which is a component of the machine learning. The power of the machine learning everybody knows. In today's world, without machine learning, people will not develop anything new. So our human beings' life will be comfortable if this kind of technology will be incorporated so that new things will be done. Who knew that in 2022 November, Chat GPT has come. There is a development. Then within 1 year, you'll be getting the complete metaverse. Metaverse, I don't know how many people you have understood or know at least. It is just like internet. If the internet, if you want to refine it, that is the next iteration of internet. That is nothing but metaverse. And for a common people to understand what is the power, what it will do actually. So metaverse is nothing but it is an emerging 3D enabled technology to create a digital space. Digital space means, for example, virtual reality, augmented reality. What is the power of that? Suppose you want to do a course in pilot, you want to fly aeroplane. Do you think that immediately just like the bike training we are giving, or the what you call car training we are giving, real system is there, driver or the assistant is there, you will be driving. But aeroplane training is not like that. Understood? So a virtual reality will be created. There you will be sitting. You will feel that as if you are flying an aeroplane. But it's not reality. Understood? So that virtual reality, to tell what is virtual reality, I can give a lecture for 1 hour. But to create that, so many mathematical concepts are there. So many artificial intelligence techniques are there. Then only it has been integrated. Just imagine how much time you have taken. So metaverse is the near future. And probably in India, we were the first company who has already engaged all its stakeholders to the metaverse. That means in the 3D, you can do all kinds of things, whatever you are doing in the internet. Understood? So I will not dealing with that. I will simply touching what is the difference, how AI looks like, what is this thing, what is that thing. With the same tempo, we start. Very quickly, we put the slide. Machine learning is a component of the whole AI group. That machine learning means what? It is the ability of the machine to learn and adapt. Learning is very simple. Earlier also, so many computer science techniques were there, where learning is there. Learning means what? We are teaching. A mom, she is teaching to its kids, her kids. So learning is different. But learning at the same time, you have to adapt. Depending upon the situation, yeah, you have to adapt. The best example I always cite, when a mother, she teaches to her kid, this is yellow, this is red, this is black. After a few days, it is astonished that she has not taught to her kid this is brown. But after 2-3 days, the kid will tell this is brown. Understood? This is the power of this learning and adapt. That means the child, which is experienced with little bit in input data, she can correlate or he can correlate. The new things he can understand also. So learning and adoption. Those two things are incorporated, that is machine learning. What is artificial intelligence? Artificial intelligence means how the human being thinks. That means simulation of human behavior, human thinking into a machine. That is artificial intelligence. So artificial intelligence initially when it started, when we taught, even I taught to the computer science graduates way back in 90s, classes were not that much particularly interesting. Because so many theory, algorithm, this thing, that thing, everybody, the teachers get bored as well as the students get bored. Because some what you call theoretical things were there, they are not convincing. When a topic is not convincing, do you think that you will appreciate the teacher? Never. When it is convincing us, then only you will understand. Yes, this is the right. So earlier the artificial concept was that it was mostly algorithm driven or the technique driven. But today, after 1990, something new thing has come. All the artificial intelligence techniques are data driven. not the algorithm. That means the power of the data is so high that different kinds of data. Do you know who is the biggest player of the data? It's the government. Government of India, if you see all the data, maximum who is handling the data? It's the government. Whether it's the GST, whether it's the e-governance, what not. So many data there. A particular technique you cannot rely on. There must be some technique where from the data, with some environmental learning, a algorithm itself will be developed by the machine. That is the power of the machine. Try to understand. Earlier artificial intelligence or machine learning, you give some data, input data something, some sort of algorithm you just see, then use one. But adaptation was not happening. Now the power of data is so high that you keep enormous amount of data. Okay? The machine will develop its own program. That is the key difference between the data-driven artificial intelligence or the machine learning and the quick. Next one. Next one. Next one. You see, if somebody will be confused that where this artificial intelligence, where is this machine learning looks like, where it is positioned. This diagram of seven. Artificial intelligence domain is the bigger. When it was algorithm driven, now it is data driven. Then comes this machine learning. Machine learning is a shift I told after 1990, it became purely data driven. Then today, people are talking about deep learning. Deep learning means there are so many complex problems where the solution methodology itself is not enough. As Panda sir was telling, in the GI cannot give you the edited solution. You may appreciate in India, but US may not appreciate that. Because there is no concrete proof. How it is happening, there is no concrete proof. Mathematicians, they don't know sir, how to tell you give me the proof from where I can prove. That's why those algorithms, we call it as the heuristic algorithm, where the mathematical cannot do that. Understood? So now, some of the problems are now coming, where the mathematical technique doesn't exist. You apply the heuristic algorithm. At least you are getting some solution. Is it clear or not? But what is the acceptance level or what is the accuracy level of that? By getting a solution method, that is not enough. For example, I am sending a satellite to the space radar. There you cannot take the chance. Accuracy also important. Understand? In that case, is it possible that using the today's heuristic algorithm, can I bring the accuracy into that? Answer is yes. That is deep learning. So very complicated problems which can be tackled by the heuristic algorithms or the machine learning we are talking about, a quick refinement or the next iteration of that, it is known as deep learning. Deep learning is nothing but the concept of artificial neural network. I will talk a little bit about the artificial neural network. Anyway, next one. The first, for your information, I am showing this slide. The neural network, 1946, people have thought of that. Now, today it is happening, deep learning. It took almost 75 years to understand or to implement. I must give the thanks to the McLean, a neurovisualist as well as a mathematician. So the best model is McLean Fit. It was developed in 1940. Now, the concept they have brought, but as we Indians, we understand. Same whole world, why should we accept that? You just show me a model, I prove it, apply it, then only I got it. Otherwise, not. That's why it took several years to create a model. Model means what? A thing is in evolution state or in conceptual state. You are explaining, very good explaining. You will explain. Probably I will be convinced, but the whole world will not be convinced. Let's create a model. Create a model means the physical significance, the physical behavior of any system. When you can put it into the mathematical form, then it is called a model. Unless otherwise you create a mathematical model, how will you go on experimenting on that? That will need a computer. First you create a model of any complex system. Put it into the mathematics. Once mathematics is ready, then go for coding. Any kind of language you can take. Understood? Then you put it to the computer. Then you go and experiment. Go on experimenting means what? But the different set of input combination, you can see till you are getting your desired output. That thing happened in 1956. So to the world, the first neural network model, which was called as the perceptron, when the neural network was into doing it, it was in 1957. Still, you consider why I'm showing this statistics? Because how many years it took? Just imagine. Every year people are working. Today, deep learning is happening. That means so many aspects of the engineering science, mathematics, basic science, they have been incorporated. Then only things are evolved. Yes. Finally, if you want to tell something, because someone will tell, yesterday you attended this class. What way this machine learning is different from conventional computer programming? Yes, this is the best slide to represent. In the traditional programming, what you learn in C, C++, Java, whatnot, you give the input, then you apply, write the program, then you are getting out. Is it clear? But artificial intelligence, when I am talking about machine learning, what I told in the beginning, it will ability to learn plus adapt. Depending upon the situation parameter, you take a intelligent decision. When nowhere it is written, your teacher has not taught you, neither it is written in the textbook. That's why machine learning means you give the input as well as the expected output. You want this kind of output. Okay, this is the experience. Output means the experience. Then the machine will create a program. You are not writing the code. Machine will create a program. And that program will any on unexpected input, depending upon that program, it will be giving the output. Understood the difference? So which one is easier to learn? In my opinion, machine learning is much easier. Not the what you call traditional programming. Because each statement, I'll give you an example where I'll ask you, find out the Newton-Raphson method and solve this equation. Very difficult, very elementary problem. I don't know how much of you can do. I tested with the finalists to graduates also. No, because so many mathematics are involved. So many mathematics means you have to know understand the integration, you have to know the differentiation, how we will be coding it, that is the difficult task. Because honestly speaking, those aspects we teachers are not teaching. It's not possible for us to teach everything. It is not a good thing. You give the input, you are just imagine this will be my output. The expected output, that means in terms of experience, you will create a own program. Then you give any on an input, you will be getting the output. Yes. Particularly the AI I am talking about and the artificial intelligence or the neural network which has already applied in this particular problem. These are the things or the steps you have to go. First gather the data. Then prepare the data. Preparing the data means you have to just clean it. You have to put it in the prescribed format. Understand? Because when I am talking about some of the variables, it is in lakhs. Some of the parameters of the variables as in points. Are they matching? No. That means you have to scale it. Scaling of the data, then choose a model. Any kind of a mathematical model comes with it. Then in heuristic model will be taken. Then the training phase. Then of course after the training evaluated, then seventh one is the sixth one is the hypothesis which choose. Parameter you understand? If I ask you, anybody can tell what is the parameter, what is the value, what is the constant. Many times I ask to the students, mathematics students they can tell. Parameter, variable and constant. Constant means C equals 3.4. It is constant? Yes or no? Variable, x, y, z. X is value, different value. What is the parameter? Don't get confused. Many times this question will be asked in the interview also. Parameter is something different. That's why I'm writing the parameter. Parameter is different. Constant is different. Variable. Constant everybody can answer. Variable also everybody can answer. What is the parameter? Particularly in electrical engineering, when you teach the basic electrical engineering to the first year student, they get confused. You will teach Ohm's law. V equals IR. If you change the V, current will be changed. Keeping in view that the resistance is constant. Understand? Then you get V equals IR. Which one is the constant? Which one is the parameter? Which one is the value? Difficult to check. What is the mathematical concept? I hope mathematicians they can tell better. Constant is very clear, variable is very clear. Then what is the parameter? When we are drawing the picture, when we are teaching the student, we are telling depending x-axis, y-axis. Okay, we are drawing three curves. Then the student asks, so we are plotting this curve with respect to x and y axis. Why three curves? I tell them, no, we are drawing this curve for the parameter number 1, second one for parameter 2, third one is for parameter. You might have seen in any of the engineering or the science subject. So what is the parameter? Parameter is nothing but it's a ratio of two variables. It is called a and conventional term. Ratio of two variables is a parameter. So that means it depends upon the parameter. If variables also, constant is something. So that's why here I am putting a new term, hyperparameter theory. When you're doing any kind of optimization or any classification task, anything, you are taking algorithm. Let us say genetic or a neural network. So in the neural network, why I am taking? I want to solve a problem. In solving the problem, I am using several parameters, I am using several variables, several constants. Those variables are different, x, y, z up to n letters. N variables are taken. Then these are the parameters. Then the hyperparameter, what is that? Again, the parameter is called hyperparameter means it is a control parameter of that particular algorithm. For example, in the genetic algorithm, how many population are there? Okay, in each population, how many, let us say, subpopulation are there? Then, let us say the neural network, in the neural network, how many number of neurons are taken? How many numbers of layers, hidden layers are taken? These are known as a control parameter. And in AI mode, you can talk it as if they are the hyperparameter. You have to tune it. Because you have to go there, reaching your expectation result. Till that you have to tune it. That means you have to tune those parameters. That also will change. But we will see how the machine learning process students approach. So we see first to train this data will be given. So how the data will be needed, that has been shown. Then of course, when you train it, how it say that this is correct. It validate. Validate means with a, let us say, best example or the best set, or we can say the benchmark sets. Benchmark methods are there. You test it, you compare it. If the result is okay, then you tell yes, I am. After validation, it is just like it too. No program, nothing. It is only few metrics are stored in the machine. Understand? When a machine learning you are using, finally somebody will tell there are so many things you are talking. Finally, when you are trained, validated what are there in the machines right now? No algorithm, nothing. Only few sets of metrics will be stored. Now in today's computer, if the only matrix manipulation will be going on, addition, subtraction, multiplication, how much time it will take? So nanoseconds only. That's why this is the strength of the machine learning. Prior to that, lot of work has to be done offline. But once you are bringing it to the machine and you have trained it, you have validated it, finally it will visualize. Actually, few metrics are there stored in the machine. Today's machine is very fast. Then you give some input, what it does. Multiply with those things, stored things, addition, multiply something, some elementary operation. Then you are getting the final. That is the strength, that is the power of the machine. Next. This is a very important slide. I always talk to my colleagues. For example, some of my colleagues, they are taking a student for the PhD program. Even for MTech thesis also. Why is the quality hampered? This is the biggest problem in our state. We are also, I am not blaming the student. We are responsible for that. We are just for number, we are picking the student. Taking PhD students plus whether the student's background is there or not. Even teacher's background also. If I do not understand what is probability theory, what is the discrete mathematics. How can I guide a student in the machine learning? Is it not funny? It's a funny thing. So that's why the minimum mathematics is required. Now AICT is thinking very seriously. In 2000, we are just planning for changing the syllabus. Probably the first year that we are planning. But AI is telling two things has to happen in the first year. What are those? One is the course and innovation. Because innovation everybody is talking. Innovation is anybody can take. Then you will call a multiple industry man, you tell it's a very good thing. I have innovated this, they will have things. That is not important thing is that now they are planning that basic electrical engineering, basic what you call electronics, basic civil engineering, all those things are not necessary for everyone. Rather, which is the important component which will be considered as a must course in the first year course, which is coming under engineering science. What is basic electrical engineering? It is coming under engineering science, civil engineering, coming under engineering science. They are telling remove all those things that anybody can learn. But first thing, since the future is metaverse, future is the natural language processing, all those things are happening. So we'll be talking about the machine learning. Machine learning, these are the topics. Are you teaching every student in the first year itself, not in the ninth semester or the eighth semester? So the syllabus has to be very carefully planned. There must be a course which is known as mathematics for AI. The course name will be like mathematics for AI. From that concept only I taught. You must know the linear algebra matrix for the thing, multivariate calculus, probability theory, discrete mathematics, statistics, algorithm optimization. This thing has to be there. Understand? So what is the percentage this has been also? So everybody you just visualize, see whether our as students, whether those components have been given to you or not. If not, then how can we expect that my student will excel in metaverse in your future? Why not? Next one. And now, directly, very quickly, I am going to the problem. My topic was that I want to solve a problem, multi-objective, because Dr. Panda started the time you could speak. Multi-objective problem is a real problem in real world. Whether it's electrical engineering, mechanical, space science, why so? Because there are, in the mathematics, you see, it's a book also, you can verify. If your objective function is single objective function, you can very easily solve. Because mathematical concepts are there, linear programming, quadratic programming, Quasi-Newton programming, there is. If you cannot solve, then go for the subcomputing or the heuristic operation. Like they think that. But the problem is that when the objective function is only single objective function, then probably whatever theory you speak or you have studied, this is what is right. But all the multi-objective is beyond one. It might be 2, 3, 4, 5. Normally it has been seen that when more than one objective is there, they are conflicting in nature. Conflicting in nature means suppose one is minimizing, another has to be minimized also, but it never happens. When you try to minimize one, the second objective will be maximized, which is wrong. How to tackle the mathematician? Mathematician they cannot tackle it. So normally, till now, how the people are solving this? They are putting a compromise fact. They'll see that the first objective is the second objective. Both are conflicting. If I am going for the first one, second one is getting worse. If I am going for the second one, first one is getting worse. Let us say, best way, nobody will dismiss 50% better than me. That is only theory. But in actual practice, will it happen? Particularly in our domain, I am electrical engineer. Particularly, I am working in power system. As you know, power system is the largest network of dynamic network around the world. You cannot name a more complex system than the power system. Understood? For your information, thousands of parameters are involved here. When you talk about the optimization, is very, very why I am talking is interesting plus easy to understand. Mostly, when you generate the power, you burn the coal. Yes or no? Coal were burning. When you burning the coal, that is the cost. Objective. Objective function, how will I minimize it? I take objective function. No? Objective function will be the cost. And then now, up to 1970, people are very happy. We should take the cost of objective function, how to minimize the cost. Okay, everybody was happy. Government was happy, customer was happy, as well as those products are there. Now in 1970, serious problem. Then the global warming started up. Then the what you call federal law of US strictly told no. Only cost minimization is not your job. I am not allowed to generate the power. Unless otherwise, you have to think about the what you call policy. When you burn the fuel, several kinds of toxic gases are generated. The amount is very high. Then all the generation companies, along with their researchers, they started. Came to the books, in the papers, then this optimization technique, they sat with the mathematician, they found that it's very difficult. Cost optimization is doing very high. Government is telling them 50% you have to give the weightage to that. When they started optimizing means what? Minimizing the emission levels. They found a very interesting. Those are entirely contradicting me. Now I am a producer. I should have money now. So then my interest is going. Then federal US law, they told no, you have to put the money. Change this research. How to do that? Is, you cannot say that 60% weightage will be given to the cost. 40% is the government is not happy. Is it 50-50? No. What is the correlation? And what is the tool? Who can handle this? Then people thought of this. At that point of time, there is a professor called Professor Jaggi. He started a new concept which is known as fuzzy logic. Fuzzy logic you might have heard. Basic difference. Basic difference is that whatever set theory you have studied, it is a two values logic. Either it is one or it is zero. But they thought a new process which is supposed to value. Let's just example I am citing. Suppose an apple is half eaten. It is placed in the fridge. If I ask you whether apple is there or not, what do you think? If a half is there, somebody knows that. Somebody will tell in binary logic, what is your answer? Can you tell 0 or 1? You cannot say anything. It is a two-state logic. Whatever it means, you can say. If you define a parameter which can describe its occurrence within this, that we call it as a function. You can tell, yes, sir, that apple is there with the number function of 1. That is 50%. Suppose 60% is eaten up. What percent is there? You can tell, sir, apple is there with the number function of 1. Justified? Understood? Then people thought, those scientists thought this model, the conflicting problem, they can decide it by using the policy. Then you can see logic is a multivariate logic only. How can it help? Then many people they didn't apply. Those who are developed much earlier, they didn't apply. Then they toss it between Japan and US. Japanese people, they are very good in developing the fuzzy logic. Fuzzy logic is something different. US people they didn't accept. All the washing machine, this thing, that thing, but the fuzzy logic that they apply. You might have seen that it has started from the Japanese. Fuzzy logic means what? Your concept or any problem's concept has to be described in terms of the linguistic language. Yes or no? Those linguistic language has to be processed in the machine. The computer understands what? Only 0 1. Can you understand? Hello, go there. Can computer now? Computer can understand. Based on natural language process. Those point of view, if you are not there, so fuzzy logic, those are a very good tool for the controller, but it takes lots of time. Once you develop this one, any modification you want, you cannot. Understood? You cannot understand because processing the linguistic variable takes lots of time. Rather, if the just like fuzzy set theory is having multiple value only, if that I can incorporate. Instead of 0 1, I am having 2 determines. That's all. The processing power of the execution speed will be much faster. That's why US people debated on that. You see the literature. Why fuzzy logic first tried dominating, then the fuzzy set theory. They solved this problem using only the fuzzy set theory. How they have done that way. So here, what I will be talking very quickly, 2 objective functions I will show you. Very simple, elementary. One first objective function is for the economy. Second one for the emission. Okay. A objective function, both the objective function, only 3 decision variables will be there. I hope everybody will understand what is the optimization. A function which is known as performance index. It is a function. Maybe linear function, maybe not. Doesn't matter. But in each objective function, same decision variables have to be there. Probably 3 variables, x1, x2, in both the objective functions is have to be there. If there is a third objective function, again, decision variables are the same. Understood? So 3 decision variables two objective functions which are exactly contradicting in nature. It will increase one, other one will be worse. How this problem can be solved by the fuzzy logic? So the disadvantage of fuzzy logic I told just now, it takes time to process because the crisp technology has to be converted to the multivalue. Then the final solution, multivalue common man cannot understand. Again from the multivalue to this, though linguistic value is not there, still it takes some certain time. But unfortunately, though the technique looks good, quite promising, but it is a real-time application. In power system electrical engineering, it is a real-time online problem. You cannot wait. Microsecond also dangerous for that. Because in electrical engineering, for your information, the total amount of generation has to be always checked. It must be exactly balanced by the load. Otherwise, system disturbance happens. You can see deviation, that deviation. It's an electrical problem. The inherent feature of the electrical problem is, understand? So many people argue, no, this puzzle is so much time it will take. By the time you are giving the solution by the puzzle and you are claiming that it's a good solution, by the time the system is collapsed, you can still treat. That's why, what is the next solution? Next solution, they solved the domain. They found that in the machine learning area, another two days. What is that? That will be the I have already talked about the neural network. Neural network in the initial phase, training means I have shown the figure also. That is all. 2 days back we are doing. Once it is trained, then it becomes significant. What is stored in the machine? After neural network trained, only few matrices I told you. So you resolve the conflicting nature by the fuzzy set theory or the fuzzy logic. You do it offline. Take those data, train the neural network, again it is offline. Understand? Then you put those solutions to the neural network. Now the neural network can happen or can work in the real time. Because neural network, as I told you, nanosecond takes to get the solution. Because two matrices will be stored. For this simple problem, I will show you that two matrices will be stored. Give the input, first matrix will multiply, pass it through it, then another matrix multiply for addition. How much time? So on the real time application it cannot. So the power of fuzzy logic as well as the power of neural network both have been integrated. Then only this real time electrical problem can be solved. Again I am reiterating why fuzzy logic? Because conflicting optimization. Mathematically you cannot solve it. It takes time. Because crisp domain to fuzzy domain again return it back. That will be done offline. Fine. Then I want an online solution. That can be done by the university. How they are integrated, how this thing has happened, that is done. Still something extra you can electron. Electron. Come to the math. Electron. Next one. This is the first objective function. Forget about red line. First objective function, very clearly F1 has cited, PG means is the decision value. PG means in our language is power generation, it is the decision value. As I told you, three generators are there. So three PGI means three. PG1, PG2, PG. Understand? It looks very simple quadratic cubes. So summation I to Ng. Ng means what? Number of generators. Number of generators. 0.5 A1, BI, CI. These are the constants. These are generator characteristics, mathematical details will be getting. Nothing will be solved. So if this is the objective function for the cost minimization, what is the meaning of that? You need to see dollar per hour. For generating this much of power by three generators, PG1, PG2, PG3. What is the minimum value of the generation so that the total load can be generated? Straight up with that. Second one, yes, this looks pretty simple one. It's a quadratic equation, isn't it? So this kind of objective function it will take. It can be very easily solved by the mathematical program. Then because here the students will say, so this is a very simple problem. This can be very easily solved by the what you call classical technique or the normal technique. Why you are taking the neural network of fuzzy logic? Answer is here. So for explaining the students in electrical engineering, we are showing this is the objective function. In real life, never happens. Real life the problem looks like this. You see here, same thing. I equals 1 to n number of generator. Equation looks like. Can the mathematician solve this one by the mathematical way? Answer is no. Because when you optimize, what is the basic concept? Just flexible design. Very simple. You just try to understand. This is a mode and it is all the line. Very simple concept. If I ask you to find out the peak, how many peaks are showing here? It looks like single peak. Yes or no? It's optimization problem. How the mathematician they need to do that when these things are not happening? You go on finding the gradient, that is dx by equal to 2 of the variable. When the gradient becomes 0, because this is x in x, gradient means what? Dx by dt is something of that sort. Here some value, here some value, here some value. At the peak, it becomes 0. After that, it becomes negative. That is mathematician, how they find it? They go on finding the gradient. Gradients, I hope you understood. That is the calculus we have studied. Go on finding the gradient, till the gradient, then stop that. This is the picture. Everybody likes it. But in realistic, this will happen in this case. If the objective function is like this, but real objective function is here, which is highly nonlinear, multimodal, discontinuous. As I told you, going by classical mathematical technique, your objective function should be continuous. It should be differentiable at each point. The gradient has to be non-negative. So many constraints are there for the mathematics. Understood? If your objective function is multimodal, just try to observe. Here one, here. Understood? This is a multimodal function. In the multimodal function, how many peaks are there? 3 peaks are there. If the mathematician will give them, what they will do? They will go on finding the gradient. When the gradient becomes 0, they will tell, no, this is a peak. So where is the actual peak value? Either here or here. Can you get it by the mathematics? Actually, this thing only happens by taking the heuristic algorithm. Because heuristic algorithm, as Prakash has already told, it depends on the stochastic rate. It depends on the random number. Random number is having a power that it can skip many steps. You are not going by taking the continuous gradient. You can skip. So this genetic algorithm or the what you call PSO, what they are doing, the technique is such that there are 3 peaks. So they are iterating. So they are skipping the first peak. There is a chance. They are also skipping the second peak. They are reaching to the actual peak. Always it may not happen. That's why multiple wrong has to be done. But there is a chance at least. But in mathematics, there is no chance. I have solved that. Actually, no mathematics. So this is the power, this stochastic optimization. So when I am talking about this thing, you see there is a discontinuity. Same objective function. This is the realistic objective function and this is a theoretical function. How many decision variables? Again, 3 decision variables. But see, number of constants are many. It is not differentiable at each point. So try to understand when your objective function is discontinuous, not differentiable at each point, mathematical application you can. You have to go for the stochastic optimization technique, which you call it as the swarm intelligence or the subcomputing technique. Various names are given. Examples are PSO, genetic algorithm. If you look at all the domain, you will see that this is the common. They don't follow the mathematics. They follow on the basis of random number. So power of the random number is so high that there is a chance that they can skip the discontinuity, not negative gradient. They can what you call skip. There is a chance that they can reach to the actual global minimum or the maximum depending upon your problem. Anyway, next one. So first is second objective. Next. Second objective function. Again, same 3 number of distant variables. Again, same problem. Alpha, beta, gamma. These are the constant for what? Emission power supplied by the manufacturer. And manufacturer like the Bharat Heavy Electrical Limited, when you purchase a generator from them, they will provide it. So these are the types. What is the expression? Because the emission is measured in pound per hour. Then you multiply by a certain factor, it converted to the money also. Same. So this is the theoretical one, and the actual one is like that. There is a discontinuity, exponential function is there, mathematical conversion. This is the reality. Understood? So classical techniques you cannot solve. So both objective function, whether we are taking the linear one, the first one or the second one, doesn't matter. Even if it is simpler, you cannot solve by your classical technique. Because your classical mathematical technique takes only single objective. Two objective function cannot be handled directly. Unless otherwise you do some transformation, something you adjust or you can. Till now, a multi-variable objective function has not been developed by the mathematics. You take the compromising factor or scaling factor when you put it in, they don't take it as. So therefore, this domain has to be transformed into the fuzzy domain. That is the power of it. That means two objective functions will be translated into a single fuzzy decision making function. How we are doing it? That's the next one. Yes. Objective function only that is not sufficient. Any optimization there must be some constant. As I already told you, there is some equality constant and some inequality constant. Any optimization problem, we the people who are doing the research, even if there is no constant, still deliberately we are trying to put some our constant. What is the reason? The reason is that objective function is the giving. Either we are searching for the minimum value or we are searching for the maximum value. Just imagine what is the source value. So big, there is no limit at all. When you put some constant on the decision variable, it gets squeezed. So that is easier to again penalty function concept, whatever Panda was telling, same thing. How your source space has to be squeezed. If the source space will be squeezed, it is much easier for a computer to find the change within minimum. Okay. So this is a constant, equality constant. I have already told you our electrical power system is such that total generation must be balanced by the provided that the transmission lines are lost. But actually some losses are there. Loss factor or whatever losses in transmission line, it depends upon A and the generation. If the three generators are generating different, losses will be different also. You see how complicated. So complication has been properly. How this thing can be solved? First one, two objective functions are there, both are conflicting in nature. My job is to satisfy the economy, satisfy the vertical emission. At the same time, this has to be maintained. At the same time, this has to be maintained also. How these two objective functions will be translated or transformed into a single objective function. Once I am getting a single objective function, then I am happy. I can go to Mahendra with the mathematician, we can do anything. It will be single objective, I can solve. How it has been done? That is next one. This is inequality constant. First I showed you equality constant. Inequality. I am taking three decision variables. Each decision variable is having a lower bound as well as upper bound. In the last class you might have seen PGI, that is PGI mean, that is the PGI. Next. And first I will to explain you how the neural network, what are the inputs you have to give, how many types of neural network and which one I have selected. For those who are new to this domain, you can see artificial neural network, the computing elements are called the neurons. Way back in 1946, this concept was given to the world by the mathematics. So, neural network, how it's solved? There are at least three layers. One is known as input layer, another is the hidden layer, and last one is the output. Input layer means how many inputs you are taking for your optimization problem and how many outputs are there. In this particular problem, which I have called, I have presented how many inputs are there. What is the problem trying to understand? I am having the load 500 megawatt. What is my answer? What I am going to do? I am having three generators. Understand? So to meet 500 megawatt, each generator should provide how much? So that forget about loss. X1, X2, X3. Three generators. It should be equal to 500. If loss component will be. What to do the X1, X2, X3? So that it will 500. There are millions of vertical combinations. Is it not? X1, X2, X3 is 500. If I will ask you how many solutions you can find, Is it not billions of solutions? Billions. Your objective to find out that what is the minimum value. You have to decide the x1, x2, x3 value so that it happens to be 500. And you will put it into the original objective function. Find out the cost. Which one is the minimum? Very difficult to find out. Because millions of possible combinations are there. Had it been one single objective function, still it's okay. But there are two objective functions. Once you are trying for the economy, other one is getting disturbed. Vice versa. So how to tackle it? By taking same concept and putting it in the function. So this is the second part. Slide has come earlier. So neural network here I need to say in my input I will give you only one. What is the load? 500, 600, whatever. What is the output? In this example, output is only 3. x1, x2, x3. Or pg1, pg2, pg. That's it. What the next one? These are the types of neural networks. I don't think I can tell you. That's how the neural network works. That also anybody understand. There is a target output, then there is a computed output. Depending upon the target output and the computed output, a error is created. That error is given as a feedback. Some people they call it why back propagation people are talking about. As if the error, whatever you are computing, that propagated towards the backward direction. So that the learning of the aid, when the error is there, something is happening in the neural network. So that again the actual output is you are calculating till the obtained output and the actual output. Actual output is target output. The error is within a tolerance band. Particularly we are taking at 0.002. Some square error. Is it clear? One is actual, another is computed. Or one is target, another is computed. Depending upon the error, there is something happening, mathematical something adjusted, so that some value are updated in the neural network. So that is how neural supervised means what? For a neural network, as it is good, the input has to be given and the expected output also given. That is known as a test. For example, in this example, what I have told you, input is 1, total output is 3. 3 generators produce. So 10 such examples you cite. If the what you call input is 500, what is x1, x2? If it is 490, what is x1, x2? If it is 400, what is x1, x2? Understood? Each teddy pair means its input and its corresponding output, which is known as the target. Similarly, 1000 set, 10 set, 15 set, it depends on you present to the number. So that means input you have given in the training case and the target output also you have fixed. Understood? Then you give a new input or any same input you are giving. Something with multiplication, something is going on there, then you are getting some neural network output. See the difference. Target you have already given, then the actual you are taking. You see the initially the error will be much higher. Depending upon the error, something will be adjusted in the weight, in the neural network again. Something will be adjusted again in the second iteration. Probably the computer output will be close to the target. Still, the error band will be less than 0.0. Normally, they will say that neural network is trained. In either case, if you talk about the back propagation normal design, what you see that there are two weights matrices. Input with this is W1, this is W2. When the neural network is trained within the band, finally neural network what is stored in the machine only two things. W1 and W2. Two matrices are really stored. Now any new thing will be at the input. This matrix will multiply, pass through the neurons, then the second multiplication, pass through the output. How much time? Nanoseconds only it will take only. So out of 2, this is the back propagation, there is the second one, the radial. I am fascinated to work. Most people, when I have done the neural network work, much before 95 onward, I always prefer this. This is known as radial basis neural network. Mostly, why I am taking? Because in the next slide I will show you. Here the control parameters are difficult. How many layers I will take? That is a judgmental thing. Even if somebody will tell, I will take 2 hidden layers. Then in each hidden layer, how many nodes I will be taking? That is again hit and trial method. There is no complete truth. Nobody can tell you. In the book, it is not documented. That means to configure a neural network, I can profession. It's a serious flaws are there. Till now in the book, nothing has been documented. The researchers, they have not given any clue. Only by experience, if you believe me, somebody will student will come, sir, I take 3 there. I tell, okay, you take it. But that is not the correct answer. I cannot give a proof of that. So that means in neural network, you choose whose architecture is auto-configuring. Understood? 2 washing machines we have taken. Earlier, when we are using that time it was not automatic. Now, in between, semi-automatic has come. Now, people are preparing with a higher cost, automatic. What is the reason? Automatic they are taking because to do any activity or any job, there are several free parameters. When you are going to the market, shall I go by bike or motor or take an auto? You are thinking now. You can go by bike, this route of that. Again, the control parameter. You can go by bike. What should be speed? Again, third control parameter. You work a particular job, a system can work fine if the number of control parameters or the free parameters is minimum. Understood? So, taking a back propagation neural network, there are several control parameters which you have to choose. No teacher can help you. It is never documented also. Only experience can help in such a way. That's why should I go for the neural? It's back propagation. Though my teachers are advocating for that, though it is well documented, rather expose duty. I always choose a neural network which will be autocomplete. Autocomplete means how many, this is my problem, how many hidden layers will be there? I did not decide. The algorithm will decide. So this is the job to take a one, not take a. Not only that, even if one, how many hidden nodes will be there? That is also not heuristic in this case. Automatically it will decide. Then which will be better? Whether back propagation or the radial basis. Radial basis function, some of the papers you will see, even in my papers I give the name, it is the super fast auto-configuring neural network. Though many books they may not document this slide, still you can consider this is a super fast and auto-configuring. So first thing is that it is auto-configuring. Why super fast? You see the system. Here, 2-weight matrix has to be trained and stabilized. Here you see, only 1-weight matrix has to be. To train a weight matrix, it takes lots of time. Thousands of iterations will take. Why? Because depending upon the target and the computed one, in each iteration, we are getting some error. Depending upon that error, these weights are modified. Understood? Lot of things you have to understand critical also. Not much time, just for your understanding, let me tell you. In the back propagation, these weight matrix have to be stabilized by the training either and this one. But in the radial basis function, this is not weight matrix. That is only what is the Euclidean distance. I hope the mathematicians they can understand how a n-dimensional input vector are close to another n-dimensional or r-dimensional vector. That closeness is calculated by Euclidean norm. Again, the famous mathematician. Euclidean distance will be measured here. Not the training happens here. Training will happen here. That means anybody, if the training is absent here, which one will faster than? This one will faster. So this is super fast. It has been observed that job has to be done by the back propagation. If it takes some minutes, job can be done by the radial in some seconds. That's why it is super fast. Why auto-configuring? No need to bother about how many hidden layers, how many hidden layers. That's why I discussed this. That's all.
Because more papers are found.
No, because of their job, even radial basis also, all the realistic control algorithms you see, they are because of radial basis. That is the debate. That will discuss later on. The next. Already I have talked about. Next one. Different types of activation function. Next one. Have this radial basis matrix little bit I have shown. Those who are interested, they can correlate to the diagram, they can find. Next one. Let us go how the fuzzy domain functions work. Next one. Next. I have already talked about radial basis. Next one. Yes, this is the domain. This scheme has been developed by us my system is still many people they are working on this depending upon some change. Since the name I have chosen, multi-objective, this diagram is not limited to two blocks. It can happen 10 ones. It's multi-objective. Only two particular to explain you I have taken. It can extend it. First objective, second objective. What is the first objective? What is the objective of the first objective? To minimize the cost. Second one, also minimize, but then they will never happen. If you try to minimize this one, this is getting worse. If you try to minimize this one, getting worse. That is that is a compromising solution in the position. That can be only given by the position. No tool other than this, no, you cannot expect. So, first objective is minimized. This is also minimized. Mathematically, it has been derived that if both will combine, then you will be getting a single objective function. But that objective function you have to maximize opposite. Then only this will be minimized and this will be. And proof is that I can prove. Are you getting it or not? First objective function has to be minimized. Second objective function also has to be minimized. My point is that had it been a single objective function, I could have easily done because mathematics is involved. It never happens. So that's why first objective function I have to minimize, second one is minimized, which are not happening at the same time. That's why I want to create a fuzzy decision making function in the fuzzy domain or in the fuzzy set domain. That transform function I have to maximize so that both the objectives will be minimized. That is the concept. Once this is maximized, I am getting the solution, but till now, up to this one, it takes a lot of time. It is done normally offline. But the problem I have chosen is online problem, a real time problem. I cannot afford that much time. Exactly those solutions up to this offline. I took it, I put it in a neural network. Which neural network? Created it. Why? Because it is automatically and it is super fast also. That's right. Now the problem of the neural network is some advantage is that I can get the solution within nanosecond, not microsecond, within nanosecond I will get, which is quite capable of utilized for the real time or online activities. But the problem of the neural network is that any kind of neural network, the constraints are valid. Because what is a neural network? This is the input that is out. Then mapping is done. Once the mapping is done, it takes the input, multiply those things, then come out. The constant, what is the constant I have to consider here? X1, X2, X1 is in the upper bound and the lower bound. Second one is upper bound, lower bound. You cannot expect any neural network. The constant will be always. So that means a preliminary schedule I can see. Many people just stop. But I cannot stop. It's a realistic cost. People will not accept it. So, neural network, though first solution I will be getting, that is my expectation, but I can consider assume it is a preliminary. Why so? Because some of the constraints will be high. Those constraints, how I bring it within this constraint, that is the challenging task. Then the whole domain, mathematics domain, this thing, that is, yes, no such. For example, x value should be 100 to 30. Maximum limit 100, minimum 30. But in my neural network is given that in some cases, x1 value is 29.8. Can you accept it? No, limit is 30. But neural network cannot give you guarantee that it is 30. No. It is a training. From my knowledge, some exploration is going on, then some such. That is the result. So that constant violation I have to remove so that what will accept it. For that reason, I have first no mathematical concept, no other technique. That's why I have created heuristic movement. Heuristic, what is the meaning of heuristic? Such. There is no thumb rule, no guidelines, nothing. You can't prove. The way you are thinking, probably if I do like this, things may happen. I tried it, that's it. It is even fine. But only like my problem is that I cannot say to the world that this is the technique by which it is. People ask me to prove I cannot. What is happening? I can show you. This is one. All the other things heuristic when you're talking about heuristic, beta heuristic, when you talk about Many intelligent students they ask the teacher, so what is that heuristic? What is that mega? What it is doing? What is the good thing? Anybody can tell. But what is the limitation? Many people hesitate to tell. Lot of what you call limitations are there. So just like that, I am applying, don't apply. Where the situation demands. So finally, I talk to every student three things. There are three tools which are very important for solving any engineering discipline. Any line. First one is the neural network, fuzzy logic, optimized math. Where you are not, that is the question. When you want very fast solution, real time application, then only neural network. Neural network is the worst. If you compare these three domains, the worst answer will be by the neural network. Because neural network is a function approximation tool, a classification tool. Because mathematicians know where you are reaching. How can you expect the answer will be correct? When the first answer, very first answer I want is a nanosecond, then only choice is the neural. Secondly, when the ambiguity there in the problem domain, you cannot understand. Mathematical also you cannot explain. And conflicting nature objective function I am talking about, nobody can help you except Fuzzy. Same applies. At first cost, Fuzzy logic it takes lots of time. If it is offline problem, do it. But if it is online problem, don't Fuzzy logic. Because the domain has to be translated. Binary logic has to be translated to multi-value logic. Then by takes time. What about when this object conflicting resolution is what? Then you apply. Third thing, if the optimization problem, maybe minimization or maximization, depending upon the situation, if your objective function is state means what? It is differentiable, it is continuous, then it's a single model, unimodal, not multimodal. Then you are bound to get a single answer, unique answer. That is go by the mathematical. In the MATLAB, various tools are there. How to solve linear programming, quadratic programming, Gaussian-Newton programming, what not, very. But if your objective function, which I consider, if there is discontinuity, gradients cannot be found at each point. That means it is not differentiable at each point. Then mathematics cannot help. What is the solution then? That to go for the heuristic approach. All the time, genetic algorithm, PSO, every day new algorithms are coming. What is the proof? They are just simulating one kind of operation in the birds. Birds are flying. Oh, why they do birds are flying in this direction? Probably when they are going by this way, they are taking the shortest path. What is the operation? After Bayesian solution, you have to take the shortest path. Then the scientists know, oh, this, how the birds are going, they even to the birds they choosing, and how the birds are moving, all the derived birds they are such. Then they are simulating their behavior in the machine. Anyone. What is the proof? If I ask you, mathematical is the same thing happens. When I saw after this Fuzzy domain translation, then the resolution. Some of the constraints. I have taken a very simple problem. Three variables only. Still, either lower limit is slash or the upper limit is slash. People will not accept this one. Understand? Then you have to go for the heuristic. How this heuristic has happened? It is unique. Only I have created. People after it tells that, sir, can I apply this? No, your problem is different. You think of the limits. Is it clear? Anyway, that with the numerical things, I will extract it. I think you know. Here I have to say, here it can be very good. Each one you create by decision making as a combine. After combination, you make. Next one. This is very important slide. How the Fuzzy to understanding this one. When any kind of multi-object you are handling, the concept is that you have to search for the non-inferior solution. I don't know how many of you in the mathematics they have understood. This illustration has been captured in the Fuzzy domain. From there it is possible. I told you very simply, F1 you have to minimize, F2 you have to minimize. For that, you translate it to the Fuzzy, add it, then you maximize it. Theoretical this to minimize. I told you that, na? That thing is happening. You have to find out non. So this is the solution space. Okay, this is solution space. Objective function 1, objective function 2. You tell me each. This is the solution space means what? In mathematics, everybody can understand. Any point is the solution. there will be millions of solutions. Out of that, you pick the minimum one or the maximum one, depending on your objective function. But if it is multi-objective function, it will not. Multi-objective function, though the solution space is quite big, only you have to search not in the entire domain. Because the entire domain is a feasible solution is not possible. They can only happen in this class. This space is known as non-intelligent solution. Because what does it indicate? If you want to minimize one, automatically the second objective is getting off or going towards maximization and reverse is true. You see here. Objective function 1 initially it will achieve. Let us say if the objective function is moved here, then it is getting worse. Objective function 2, if it is here, it is the minimum. If the objective function is here, it is getting worse. This thing only happens. Take a point here. Objective function. Take a point. This one. If I want 9, F2 should be better. This side. Then what is the objective function? F1. It is getting most worse. That's why it is not. Same concept has been very easily. What you call? It is the power of the positive set theory that this has been incorporated in the process. That's why when there is multi-objective function, take individual objective function, modify it, what you call? Take the membership function concept, modify it, then add it up. So you are getting single objective. That will maximize. Once you maximize means achieve, you are minimizing all the individual objective function individual. That is the whole story. That is the power of system. Next one. Next one. Illustration also have given. Next. Yes. How to falsify that important. When any objective function will be given to you, there are two values. One is the minimum value, another the maximum value. Do the minimization, do the maximization. Two values will you get or not? By any method you can get it. Those two values take. This is minimization of any objective function. That I will written FC. C means what? Cost. A means just some value. Same objective function you maximize. You will get inverse solution. That I will written. So that means your solution is so that your compromising solution will be definitely between. This is the minimum value. This is the maximum. Clear enough? But we don't want the minimum value because when I am going for the minimum value, the other objective function is getting worse. So I want something between for the second objective also same. Understand? This is the membership. Again, depending upon the complexity of the problem, your membership function will be different. That is another story. You may not understand this. Different kind, non-linear, very typical behaviors are there. That physically go to the problem. What is the relationship that you have to understand? Then only can choose. But it's the very simple. Naturally, 90% of the people, when they are going for the logic domain, they are going for the linear, decreasing linear. That is the best. And probably using this one also, it is much easier to do. So, to quantify it is objective function, two things are necessary. One is to minimize the value and its maximize. And it is expected that the compromising solution will be in between. Now, from this figure, if I take my membership function is 1, means what? I am satisfied fully. Because membership function 1 means minimize. I want the minimum solution. If the membership function will be 0, the maximum one. I am not satisfied at all. Understand? To quantify these two values, how this is written like this. F1 after quantification, take V1 membership function or ith objective function, which is a function of PG only, which means number of distant variables. H1, H2, H3. Fit minus FIPG. FIP means what? Maximum value divided by FIP. So now to classify objective function, for each objective function I must find this one and this is a common thing. But depending upon the expertise of the decision maker, which is really taking the decision, this FCD may be changed. In some cases, this FCM also this can be changed. If you want the constant, if you know that my compromising solution will be like this, why should I take such a task? This is the extreme case I'm talking about. It depends upon the decision. Next, first objective function will do, second objective function also do, third one also will do accordingly. Next one. See how it is written in the program accordingly to that. Then, if I have qualified both the objective function, then the positive decision making function it's a summation of two. That's all. Very simple addition only. So, C means it now maximize that. Why maximization? That I from the non-inferior solution range only it has been translated. So now minimizing both the objective function means maximizing the positive decision making function. How the positive decision making function created, I hope you have already seen that. Next. This is how it will code it. It's very simple. At least maximum 30 lines code will be necessary. This is not available in the toolbox. You have to create that. Start input the system data, system parameter. How many generators are there? What are the cost coefficient? What are the emission level coefficient? Whatever you have talked about, those things. Then compute the loss coefficient. Since it is an electrical power system, so loss which is again dependent upon how many generators are there. So you have to compute those things. Then minimize here the actual understanding of minimize each objective function separately. Why so? Because in the qualification, two things you need, two parameters. Define the membership function also. Then form the positive decision making function. Then you maximize. Your job is done. Then you check. If the solution is satisfactory, no. If not, what can you change? What can you modify? Only the membership function. How will you change the membership function? I have already narrated. Not necessary maximum value and the minimum value. Can you switch also? Yes or no? That depends upon the decision maker's expertise as well as experience. If it's satisfactory, then stop. So now, all these things are happening offline. All the possible combinations are tried. Because now I am taking this one as a correct input output to the neural. This is okay. But it takes lots of time. Understood? That's why I want a very fast solution. Unless otherwise those solutions will be trained by the neural network. It is not no use. Now, let's go. Neural network. Neural network, see, I already talked about input P means pattern, then output. Each training pattern is particularly in my case, what is the input? Single input. It is total load. What is the output? It is having three things. PG1, PG2, PG3 or X1, X2. Lacks of combination I can compute by the Fuzzy domain. Can I not? Those things I just put offline and computed. Those things I put it. Next. So first at the insert creation, those things already I have explained. Up to this one I have already explained. Coordination of economy emission by the Fuzzy coordination method with the Fuzzy process. Then optimal solution of multi-objective general by the Fuzzy coordination. Then you go for the neural. Next. The neural network what it does? If the input two matrices will be multiplied, then you get it. That's what is happening. But the problem I have already explained, some of the limits of the decision variable, x1, x2, may cross this kind of that. How to do that? That's why direct solution from the neural network. I cannot call it as the final decision. It is only the preliminary decision. Then I applied the rule based for that. No proof is there. The way I thought it was. That's why it is called as the heuristic. Next. Yes. What is that heuristic? That is the last one. Heuristic means what? Three things are there. Try to understand. Mathematics may not understand that. Three things are there. One is crossing the lower limit, or one is crossing the higher. Not necessarily one. Two may cross also. I am talking about one. One is crossing the lower limit. One is crossing the higher. What? If one is crossing the lower limit, that means what? It is less than the minimum limit. Something has to be added to that to make it up. Let us say the limit is high. If I am putting the rest amount to the third generator, which is crossing the limit, from where I am going? From the other two. This is the truth. Similarly, if it is crossing the higher limit, then what will happen? I will remove from the higher limit, distribute among the others. Did you get it or not? Total thing should not mismatch. Only thing, the limit is the constant. This is mismatch because the neural network doesn't understand what is the constant, what is the limit. You will not understand it. Just give him a pattern, as I have already explained. Two set of matrix only placed, nothing else. he will not understand. Then why you are applying? Because of the first solution I want. That will tell you all. So the limit has to be said again. Same thing has to be edited. Since time is not, I am telling you. Three things are there. One is crossing the lower limit. Crossing the lower limit means what? The limit of that variable is 30. Now Niraj is telling is 2. One is less, you make it to the lower limit. The other thing cannot do that. So instead of 29, you have to make it. People make it 30. In the total thing, x1, x2, x3. Will which balance them? That one, that gap which we have added to the lower limit, that will be borrowed from the other. Divided equally by the. Understood? Same thing happens if it crosses the. Because the answer which I got initially, it was not accepted. Sir, your limit has been high. Then we thought that this can be used. It is accepted. So this is what people ask me, sir, why you have done, why equally you have divided with this? Because the rating of the generators are different. Then there is no answer. But this is thought to be it is well accepted. Similarly, those who will be working in the denominator, they are bound to face this problem. In that case, to accept their work, they have to take the help of heuristic. Unless otherwise they apply the heuristic, it will never happen. Next. Same thing, nothing more. Now numerical thing. Just in the numerical thing, I'll show you one. Next. These are the system 3 generators, 3 decision variables. Just see here. Here one of the generator most. Next. These are the generator cost coefficient. Next. This is the what you call emission cost coefficient. Next. This is what first to do. First to minimize the first objective. When cost will get difficult. How we are getting this? PG1, PG2, PG3 have got it from the optimization to put it into the option. We are getting this one. Then same decision variable, you put it into the other objective. Other objective are not optimized. We are getting some value. This is 3 decision variable, these are nuns. And these are the losses. But the different load levels. Load levels 210 is normal, particularly this system. 210 is the normal base. How it is computed, how to work with wider range, 20% here, 20% there. So around 90, take this is the base. Within some gap, uniformly, so 9 some training pattern. That is not sufficient. So since it is a linear kind of thing, this may happen. Within this range also you can create thousands of what you call training patterns. Training pattern is what? You are algorithm ready, just give the value, you are getting the answer. So within using the 9 also you can. Next one. Next one is the second objective function you minimize. That is known as minimum emission. Why 2A you are doing it? Because for the falsification, just remember, maximum minimum value has been taken for each load. This has to be taken for the minimum emission and for the minimum cost from the other table. Next one. Now falsification value has been taken from these 2 tables. All these things I am telling, all are taken by the program. Don't think that every time you open it, take this value, take that value. It's not possible. It will happen. Then, next one. So you will see that for each load level, the Fauci compromising solution, you can check that. That is already there. It will be falling between the most economical solution and most emission solution. It is bound to fall with that because it is a compromising solution. This solution has come from the Fauci. Next one, sir. Next one. Yes, that has been shown. How it has been taken, the way I told, everything has been documented. Next. Yes. This is the best compromising. See that each of the for 168 load, full application. Other 2 tables you will see it is talking between those 2 men because it is compromise. Next. Next. Neural network, as I told you in this one, there is 2 control parameters you have to decide for simulation. One is the spread factor and what is the number of what is called hidden nodes in that neural network. As I told you, it is the auto confirming neural network. The number of training patterns exactly equal to the number of hidden nodes. How many hidden layers will there? Since it is auto configuring, it is bound to have only one hidden layer. Unlike the back propagation network, that might 1, 2, 3, 4, n number of hidden layers. But in the radial basis, only one hidden layer. Input layer is fixed, output layer is fixed. Hidden nodes also is fixed. That's why it's copy continuity. Remember, the number of training patterns will be exactly equal to the number. Only one control parameter the user has to choose. That is the rate factor. Rate factor means width of the radial basis function. Because the radial basis function is just like Gaussian. Gaussian distribution can be very steep, can be very wide also. So the training or the intelligence depends upon what is the width of that Gaussian distribution. That is the only three parameters which user how will do. He assumes certain value, take the neural network, then find the mean absolute error, then you compute a count. Several error factors are wide. We see the part where it is minimum, mean absolute error, wherever it is minimum, you tell that the corresponding error factor fits the best. Normally what happens? For more accuracy, for each hidden neuron, you have to find a factor value. But generally, normally the people who are working on that, a single rate factor is sufficient for all the. That's why radial basis function I always advocate, and it is converging to the solution. How come error is calculated? I have to show also. F means faulty, PCI NF means 0. So the error calculation, both the results are there. You can always verify from the table. I will short. Next comparison is there. My conclusion last slide is last slide. My conclusion is that in this case, though the simple problem are taken, then the classical optimization techniques are used by the MATLAB to find out the exponent. That's very small. When the nonlinear, very complicated object function will be taken, then those optimization, linear optimization has to be done by the genetic algorithm or any algorithm. Only two objective functions have been decided, but in actual, for us also, in power system engineering, there is a reliability index. There is a limit to higher total power flowing through a transmission line. So several aspects can be taken of the objective that can be extended. There is a size of the decision variable. Size of the decision variable here we have taken 3, but it is not limited. Thousands of parameters with the same algorithm you will apply, provided that your MATLAB is having that much dimension. It can be easily performed with the system can be done. More number of objective functions can be taken, and more illustrious heuristic optimization technique will be applied, provided that your objective function 1, 2, 3, 4, 5, many objective functions, they are really very non-linear, discontinuous, and multiple. Then you go for the other one. Last one. That's all. I'll be happy if somebody will ask few questions. Anybody? Ask? We'll stop here.
This is known as the exact science. Mathematics is known as the exact science. Suppose we cannot prove something in mathematics, but we provide the conjecture. In the other conjecture, you do some experiments and.
Yes, that's why the whole idea of data analysis, why it has happened. The main objective of data science is that already some hypotheses, some multiple laws are there. Even in physics, chemistry, some laws are there. Till now, many people are struggling. They are trying to disprove. Don't think that whatever Einstein has told everything is correct. Okay. Now the world is not believing that. So then what is the proof? Proof is not there. So through the data, when the thousands of data you are having, any domain you tell, data can be data are there. Then from the data, again heuristic application I am talking about. Oh, what is the trait? What is the relationship between these traits? That has to be found out. Then you can disprove or prove the model that data analysis is doing that.
The scientific community will accept this.
Yes, obviously. I can explain you with the data sets. I can show you
Journals
that.
may refuse your method as
No, not necessary. Always like when you are public journal paper, we are telling that all the students we are talking, and you have got your answer. Why don't you compare with it? And comparison के लिए कुछ होगा तो आपने compare करना है ना. Comparison के लिए कुछ method होगा तब जाके करना ना. Don't expect that unless otherwise it's validated. It may not be what you can compare with the standard one. But there are ways to convince the world by your answer, by your model, by your realization. What will accept that? Why not? I told you in the best example, when the neuron concept has come, people 20 years have passed. Then some people came, they electrical they draw a model. Electrical model in what? In electrical engineering, we understand only resistance, inductance, capacitance. Three parameters. Through that I explain. Training is done like this. Then why not?
Neurons, what my idea is, footage also, people thought it negative, something like brain matters.
It is not a story. And my point is that something is also okay. By using the neural, I want a very what we call swarm intelligence we are talking about. There are the parallel sorts. In the mathematics, we are not finding the gradient. Each happens step, second step, third step. But heuristic algorithm are not that. Thousands sorts are doing that. Then we are picking by certain gradient. Similarly, they are not far ahead. When this neural network concept, the computer will be developed like that. No need to write the program, this is that. Automatically, it is really. No, your concern I understood. Unless otherwise you standard is compared with some standardization. You are expecting that your paper will have. No. With the illustration you can show with the reference, with the recommendation, with the comparison, with certain of the paper. Not necessarily your result will be again not by others. My point is that when you compare, when there is a benchmark, well tested, well available, then only you can compare. If you know, you can create a new thing. Why not? Then one has to believe. May not be day within a day. Maybe after 2 days or 1 year, it will be done. Be positive. Okay, thank you all.
Thank you, sir, for delivering such an amazing session. It was very nice to have you among us for today's event. Now I would like to request Professor Mahendra Kumar Jena, sir, to present a token of appreciation to Professor P.K. Hota, sir. So,
This is last paper that it is. Right? Last letter. The whole one last letter. Yes. This is not way back, 20 years back, nothing new. Same thing I just presented. So that this part has been done. Do to make up. Okay. Okay, can you start working with this? Out
now we have completed the second session of today's evening. There is a short interval before starting with the next session. We would like all of you to step out to the cafeteria for the refreshments.